Spatial Innovations. This is Matt Schellenberger. He's with American Electric Power. We'll talk a little bit more about our backgrounds. But what we wanted to do today is talk a little bit about cloud computing, give you some of the fundamentals, basics of that. We're going to have about 30 minutes. We'll talk about 20, 25 minutes. I'll touch base for about 10 or 12 minutes and then turn it over to Matt. So, what we wanted to do with this short time together is really not make you experts on cloud computing, but you hear about it every day. You hear about Apple and the hiccup that they had a couple of weeks ago. You hear all the Microsoft Azure commercials, and it's just everywhere. So I wanted to just take a little bit of time and talk with you about Azure, or talk about cloud computing. Not to make you an expert, but first talk about some of the fundamentals of what cloud computing is, some of the language and lingo. We'll talk about the benefits and risks of cloud solutions for your business, and we'll talk about which applications might be appropriate to consider for the cloud. So we'll touch on these types of topics, and then in the context of this, we'll show how a company can actually put that into motion. So my company is called Spatial Innovations, and what we do is we collaborate with utility companies, energy companies, to develop applications that are really targeted to solve a problem for the field worker. And so we have a collection of these tools. This tool here, GSI Scout, the Storm Damage Assessment tool, we're in the process of working with American Electric Power to move that from an enterprise application, an on-premises installed in their environment, in their servers, to a cloud application. So we'll talk about how we're able to move that over, and the types of benefits that you get and the challenges you get moving from enterprise architecture to a cloud architecture. And you might not have heard this term before, but we eat our own dog food. And that is, we're a software company, and we develop these cloud applications, this cloud software, and we're talking to our customers about these types of solutions. But we also use these solutions in our own business, to run our own business. Things like Visual Studio, we use that for our source control. So all of the software, which is the foundation of our business, we trust that to the cloud. We don't keep any of our software local. It's not on our local servers or desktops or back it up. That's all in the cloud. And so when our developers are doing their work, they're working individually, but when they check things in, it's going to the cloud. QuickBooks, for all of our financials, all of that information is cloud-based. So we're able to access that information from various parts of our business, from our teams down in Austin, Texas, to here locally where I live, to people throughout the organization. We're able to access that. AxoSoft, that's a type of software that we use for our Scrum and our software development to track the features and the backlog items and how quickly we develop the software. Microsoft Office 365, that's all your Word, Excel. We use Link to communicate across the network, but it's all cloud-based solutions. So all of these things, we're not only out there talking about our own software products that we work with our partners like American Electric Power, but we count on these types of systems in-house to run our business. So just the typical kind of architecture of what we're talking about, these are sophisticated software solutions, they normally involve a database, right? In our case, it's SQL Server, but it could be Oracle or anything else. There are field workers, and a lot of times these are the people who are out in the field collecting data. Might be on a tablet computer, a laptop, phone, more and more. So these are the technical workers that are out there capturing the information where the assets are in the field. Normally they're using peripherals. GPS could be, mapping grade GPS that give you accuracies of 1 to 3 meters. Could be survey grade where you're down to sub-centimeter. We could be using other peripherals like laser rangefinders, barcode scanners, anything else that helps you capture that information more quickly and accurately. We have websites to be able to view the data, and Juan made a great point and lots of things that we could take away there with telling a story about how you display the data that you've captured in the field. And then these systems cannot operate in isolation. You need to integrate them back into your other systems back in the office. In the utilities, oftentimes you have an OMS or an outage management system or a work management system or a GIS. So there's lots of different ways of integrating this back together. And then the business analytics, making sense of the data that you've captured in the field in the context with other information that you have. So this is a complex slide for a type of enterprise application that might support 5 users in the field. It might support 500 users in the field. So very sophisticated, very integrated. But when you get down to it, you're really just talking about people in the field using devices, the concept of bring your own device. I might have an Apple iPhone, might have an Android tablet, whatever it is. You're capturing data in the field, and then you have workers in the office. It might be the same person that does work in the field and then comes back in the office. Or you might have a separate person, somebody that collects data in the field, and then back in the office, somebody else makes sense of that data or aggregates it together into other systems. But behind that, it's all in the cloud. So what does in the cloud mean? Well, let's talk about it in the context of comparing what on-premises means versus cloud computing. So all of our solutions were on-premises until a few years ago. That means that when we came in and worked with a customer like Matt, we would take our software, install it in their environment, on their servers, on their network, and they would be responsible for managing all of the servers and all the infrastructure in-house. And we would just work with them to bring our software in and install. So for an on-premises solution, you talk about different things here and how that compares to cloud computing. So in data redundancy, you might have a single server. Well, how do you make sure that that is all backed up properly? Well, you might have a backup drive. Maybe in fancy situations, you would have maybe 2 servers. If you needed to have critical uptime, and one server would flop over to the other in case of a failure. Well, in a cloud environment, there's normally, you can have 3 or 4 or 5 different environments running all the time. So if you had a failure in one particular instance, it would automatically fail over to that. Performance, that comes back to the individual server, right? If you have a server that's moving, with its memory, it defines out how quickly it is. In a cloud computing environment, you can have it auto scale. So depending on what kind of workload it has, if it's real light duty, it allocates a certain amount of resources. If you have a lot of heavy duty, it allocates more. The IT requirements, you know, whether it goes to the vendor responsible or whether you have the in-house employees, cost, pay as you go, and then the upgrades, who is responsible for that as well. So what does this whole cloud mean? You know, when I talked about QuickBooks and I talked about, you know, Salesforce.com and other applications like those are software as a service, meaning that all I have to do is log on to my website here, and I'm able to run the application. I can enter new data, I can maybe load it from a spreadsheet, but everything that I need to run that application is right in that website. I don't have to do anything else to it. You know, they're responsible for security, the vendor's responsible for, you know, all the networking and making sure that there's enough storage and all of that. That's software as a service, and that's sort of the easiest approach. Infrastructure as a service is kind of the other side of it. You know, I talked about the, in an enterprise architecture, you have this large server where you set up install a database, you install the application software, you have networking, you have to maintain all the security. But infrastructure as a service, if you don't want to have all those servers in your house, in-house, you can just go out and get a server from Rackspace. You can define what kind of server you want, whether you want redundancy, you know, what kind of network speed you want in there, what kind of memory, and you can define all of that. So they provide all this hardware side, servers, the visualization, the server hardware, storage, and networking, and this is the part that you would put. You would load your application software on there, you would create the databases, so SQL Server, you would load that up, you'd be responsible for all the patches, security and integration, and the runtime. What we've done as a company is we've chosen sort of that middle ground. It's called platform as a service. So the vendor that we chose was Microsoft Azure. So Azure provides all the hardware, the servers, visualization, the server hardware, the operating system, you know, how many servers and failover and all of that kind of stuff. Security and integration, the databases, they provide the SQL Server database. So what we can do is just focus on the application software. That's what we do best. We develop software for these field workers, and we're able to come in and just install it in the on the server and be able to run that and support multiple clients out there in that environment. So whether you choose software as a service, that might be appropriate for some of your applications, platform as a service, or infrastructure as a service. Those are some key words that you might think about as you move along. So I'd like to introduce Matt Schellenberger of American Electric Power.
Yeah, so you have to have the obligatory what we serve slide. Everybody does that. Every utility ever always shows a slide of what they serve. So that's our service territory. I work on the distribution side of the house. The guys with the big towers and all the generators, that's a whole different group. I work on getting the service to buildings like this or your house or things like that. So I work in the distribution side. Part of our work that my group supports is the engineering tool. We also do more or less field survey, but you can't call it surveying because we're not licensed surveyors. So we do field data collection with high accuracy data collection devices. Mostly we use Trimble. We're one of Trimble's biggest users on the mapping GIS side, high accuracy. We're in the 10 centimeter range for most of our data collection. And then we have a few areas that use centimeter grade stuff as well. We'll also break out data collection with conventional survey equipment like total stations and things like that. So we were the big data collection people within the group. So then we got interested in helping out with storm damage assessment, and that's where GSI comes in. We've been using their products, GSI Asset Designer, for since about 2000. About right after selective availability was turned off on the GPS side, so you could do higher accuracy real time in the field. That's about when we jumped into the mix to do the data collection using GPS to feed our engineering design tool. So a few years down the line, one of our managers said, hey, you have that data collection software for doing design work, why don't you use it for doing damage assessment? And so we worked with GSI to work out more or less the Scout application to collect that data. Either at the time it was on our Windows mobile devices. Since then we've added it to PCs, and the latest release will be with iOS application, so that we can collect it on a phone or a tablet or whatever, and moving forward also on Android flavor as well. So, like Carl was saying, we've had the systems all in-house on database servers and web servers and all those kind of things internally. One of the big issues for us is if we have a big event. You saw that we serve down in Texas. So every once in a while you get a nice little hurricane that blows through and there's nothing left, right? So one of the big concerns for those folks is they want to be able to bring in assessors from outside of AEP, outside of our normal workforce. Well, they're only going to be there for, say, maybe at the max, maybe a month, right? So in order to set them all up with internal passwords and IDs and all those kind of things, kind of a challenge. Also setting up the redundancy of the system so that we have good availability through our internal systems. We think we can do a better job with that by going cloud. So that's what we're moving toward. So we're more or less taking what was that single database in-house and moving it to a cloud environment. It gives us quite a few benefits. The big one is scalability. For us to develop the same kind of scalability that we can get through the cloud would be an immense server set that would be there 24/7, 365 that we would be paying for. Well, if we move it to the cloud on blue sky day when we only have just a few activities going on, we only have to pay for this much. But during a large event, what we can do is get billed for this much. And since it's under a storm activity, we can try to get recovery for that for a large storm event, because we can be billed for that particular set of bandwidth that we use during that event, as opposed to a blue sky day when we're only using just a little bit of bandwidth or a little bit of resources. So high availability, obviously, during a storm. How many people want their power back on after a storm? Everybody? Yeah, that's what our customers obviously want as well. They also want to know what's going on. That's a whole part of the damage assessment process, is collecting what's broken, what's down, how many crews we need, how much stuff we need, where it is. I really like some of the stuff we were seeing earlier on producing that story of what's going on, because that's one of the big things our customers want to know, and I'm sure all of you want to know. When are my lights going to be on, not for like the whole city, but at my house? Because maybe I have a freezer full of food, or I have this, that, or the other, and I want to know for my particular house when my lights are going to be back on. So assessment is a key part of getting that data so that we can predict when your particular service is going to be back on. So when or which applications to move to the cloud, I kind of talked about that a little bit, is on a day-to-day basis, our use of Scout is like that. It's very minimal, right? But on a big event, if we have like the derecho, I don't know how many of you live in this area, but 2 years ago we had a derecho that blew through, and it seemed to just follow right along the AEP service territory of the east. And I think we had about 2.3 million people out of service, customers out of service, which equates to even more people, right? So pretty big thing. So during those kind of times, our bandwidth would be like this, right? We'd have tons of people coming in, doing work, and we'd want everything to be up and running and have good performance. Because not only are people, wanting their service back on, but everybody that works for you wants performance to be like that, right? So you gotta have good performance, you gotta have good availability, and we think the cloud can get us there. It can also make it easier for us to bring in those external resources and get them hooked into a cloud environment as opposed to an internal environment. And obviously the data is, critical. We don't want to lose it. It doesn't contain what we at AEP call PII, personal identifiable information. So it's not quite as, top security as some of our other data, but it's still important not to lose it. And we want to use that data going forward also to predict damage from future events and also to determine better practices on the engineering side, like how to harden structures, how to do a better job from a resiliency standpoint. So when should we move to the cloud? Well, there's a whole new version of GSI's tool, right? So we're on the 2012 SR4 release. They have the 2014 release. It has a bunch of new user enhancements. It's got an iOS app version. So right now for us, that's a good time to move. And so I'm working on the business case to write up to move us from our internal resources to the external resources. So for us, right now is a perfect time to make that transition from the enterprise system to the cloud-based system. I don't know how I'm feeling. Yeah, doing good. All right. Oh, cool. So, what are big concerns? As soon as you say cloud, oh my goodness, security, at least from the IT side, right? So we have a protocol at AEP that's set up where we run everything past our IT security. They more or less have a checklist. They get in contact with the vendor. They run through all kinds of things like the security addendum. Oh my God, that's exciting reading, let me tell you. I read through the thing. I'm like, holy moly. Okay, we're not going to nuke the world. We're not going to spread biological plague. I think we're good, all right? So we're not, that's one of the big things though, is going through that security checklist and getting them in contact with the vendor. Actually, I thought it was going to be a bigger deal than it turned out to be. GSI was able to work very well with our security guys to get everything worked out. So we actually have that part of the evaluation done. Now it all comes down to money, which is what every project we do, is can you save money, is it cost effective, so on and so forth. So that's the part I'm working on now, is writing up the business case to get the approvals, to get the funding to move us not only to the new version, but also out to the cloud. But we think with the ability to take the system and hold it at what we at AEP call Tier 0, which is high availability system, that we can do it much cheaper by going cloud than by doing it internal and having those servers and resources on site 24/7, 365. Because we really can't charge for that, because it's there all the time. But if we can charge for when we use this bandwidth and get it billed as part of the storm, then I think we can charge that. So some of the options that are out there, and we've talked to different vendors as we've been going through this emergency restoration process theme that's going on. And a lot of this, other applications that we've looked at were on Amazon, Microsoft Azure. I know, at least I've seen a lot of the commercials, maybe because I'm highly aware of it now. But GSI is on Microsoft Azure. Our IT guys are fine with that from the security standpoint. There's a lot of other critical data that's on Microsoft Azure, some DoD stuff, Department of Defense stuff. So there's some fairly critical things out there. You got all the security authorizations and certifications, and I'm not an expert on that, so I'll try not to pretend that I am. So